make myself disappear. And let's talk about or review our first system, the integumentary system, also known as the skin. Okay, so having a decent understanding of tissues will help you to understand this chapter a lot, because especially when we're dealing with epithelial tissue, the skin is going to be, well, in fact, the skin has all 4 tissue types involved in it. And I'll talk more about that as we move on. But when we're talking about the integumentary system, we're going to talk about not only the skin, so the covering to our body, but we're going to talk about some of the accessory tissues, things that were derived from the skin. Nails, hair, all right, sweat glands, and that's going to include the sebaceous glands there. And so when you've been going over chapter 5, you were learning about some of the glands there. And so now we're going to kind of throw that all together, you know, and scramble it up into this system here, all right, our skin. So a big concept that you need to understand is that our skin, all right, is the largest organ in our body. Right, so we can call our skin a couple different things. We can call it the integument, or we can call it the cutaneous membrane. And that cutaneous membrane is one of our 4 types of membranes that we studied before. You have 4 membranes. You've got the serous membranes that we talked about a while back. Then we have mucous membranes, which you'll go into a little bit more detail in the second half of this course. Synovial membranes we'll talk about in chapter 9. And then cutaneous membrane, and that's going to be our skin. And so basically, and as you know, I mean, this is a common sense thing, it's going to protect us from the external environment. So it's a barrier, yes, to the outside world. And when you get into the immune system, you're going to know that, you're going to learn that it's part of the innate immune system, which is this natural occurring part of your immune system that helps to protect you from pathogens. Viruses, bacteria, parasites. So basically, the covering on of our skin prevents certain viruses, certain bacteria from getting into our bodies. And I use the skin, the integumentary system, all the time to basically tell me, you know, somebody's health, just in general. Okay, how many times have you looked at somebody's face and they've got bags under their eyes, and you're like, oh, you look really tired? Or if someone comes in and they have a yellow discoloration to their skin, a lot of people immediately think, oh, jaundice. Okay, but what is jaundice? What's happening with jaundice? Right? Well, usually people think the liver. All right, so we use the skin to help us to determine a lot of the health of, if you're in patient care, you know, the overall general health of patients. It's very helpful. Of course, the study of skin is dermatology. That is one of the hardest specialties if you're going into the medical field to get into. All right, so some of the functions of integument, and you're going to see that when you look at some of these functions here, some of these functions are going to cross over into what we were talking about, epithelial functions. We were talking about the functions of the epithelial tissue. So the first one here is protection. I already mentioned that. Okay, our skin is a physical barrier. Right? It prevents the passage of certain materials in and out of the body. So it's going to keep us safe from certain pathogens, like I mentioned before. Also, it helps us to protect us from the ultraviolet radiation from the sun. All right, the skin actually will help with thermal regulation in situations of hot or cold temperature extremes. All right, the skin will help to either warm up or cool us down. So it plays a huge role in the actual protection of our body. Another role that it plays is the prevention of water loss and even water gain. I mean, water loss is pretty important. You know, dehydration is a problem. It's a bad thing. None of us want that, right? It can lead to a whole host of different problems, right? But what we'll see here is, right, our skin helps to retain water. Now, we'll lose water through sweating, of course, and through what we call transpiration. And transpiration is when our sweat glands just release little bits of water from time to time. All right, but we notice that, yes, our skin is not going to be an absolute barrier. We've witnessed that when we've been soaking in a tub or been in the pool or ocean for a long period of time, and our fingers start to get wrinkly or pruny, some folks will say. And that is partly because the skin is water resistant, okay, but it's not waterproof. A good friend of mine once told me, if water wants to find its way into something, it'll find a way. He's a carpenter though, so he was actually referring to building structures. But the same applies, to our skin. Another function is going to be metabolic regulation, right? So you probably heard a lot with everything that's going on with COVID, the importance of immune function and health. Sleeping a lot, take these supplements, take zinc, take vitamin C. Well, vitamin D is wonderful for our immune function. It's very helpful. There's studies going on, ongoing studies now, that they're finding out that adequate levels of vitamin D will help in combating certain types of leukemia. So yeah, we just used to think it was a vitamin, but now we're seeing it classified as what's known as a prohormone. And basically what our vitamin D is going to do, all right, when it's generated in your skin, is that it's going to, excuse me, I didn't mean to do that. I just couldn't find my cursor. All right, it's going to be synthesized in your skin cells, the keratinocytes. And they're going to produce, all right, vitamin D3, and it's going to go to a couple different organs, the liver, the kidneys, talk more about that in chapter 7, okay? But it'll eventually wind up, once the kidneys are done with it, it's going to wind up as this guy here, calcitriol. Calcitriol is the active form of vitamin D. Basically what it does is when your blood calcium levels are low, calcitriol gets released and it helps increase your blood calcium levels. A couple of ways that it does that is one, all right, it prevents, all right, the secretion of calcium and phosphate from the kidneys. So therefore it increases the absorption of calcium and phosphate from the kidneys. Make sure that you're not urinating it out and that you're keeping it in your blood. And then it'll also help to release, all right, calcium that's stored in your bones. But it plays a big role, all right, when you are digesting food, that it increases the absorption, especially in the small intestine, of calcium and phosphate from your digestive tracts, and helps to place it into the blood, into your blood. All right, secretion and absorption. How many of you have ever tried to quit smoking and you used a nicotine patch? Some of you may have had to use a transdermal fentanyl patch. My dog did when he had back surgery, and they put this fentanyl patch on him. And of course, it was a patch that was releasing fentanyl, all right, at acceptable levels for easy absorption. So we'll see, all right, that because of the skin, it is a barrier, but it's going to allow the passage of certain substances and block the others. So it's what we refer to as selectively permeable. All right, immune function, I already mentioned that. It's part of the innate immune function. So its physical barrier helps to prevent the passage of certain things from entering into the body. But at the same time, when we were talking about, well, you have to forgive me, I'm confusing your section with my other sections. I don't teach the lab section, but normally in the lab section, when I talk about the epidermis and the 5 layers, we talk about some of the white blood cells. They're called dendritic cells, or the cells of Langerhans. They exist in the second and third layers of the epidermis, deep layers, I should say. And so their job is to basically monitor the cells that are surrounding them. And so if they recognize any abnormal growth or signal markers on the cells, they'll initiate the immune response. So it's these cells that actually will terminate several types of cancerous cells before that cancer growth gets out of control. Another function is temperature regulation. We talked about that. Just a quick review, right? When things get too hot, for example. You're outside exercising or laying in the sun, right? And you start to sweat. Your blood, all right, is going to go to the surface of your skin. And the reason for that is because the blood is usually 1 degree warmer. And so when it moves to the surface of the skin, it helps to give off the heat that that blood is carrying. So the blood vessels undergo what's called vasodilation. They get bigger, so more blood can go to that area. That's why you'll see in certain folks, especially folks that are fair-skinned, when they get hot, their face turns red. And that's because the blood vessels and the capillaries there, well, not the capillaries, excuse me, the blood vessels, the arterioles, have vasodilated, so more blood can travel to that area. And then the reverse occurs in cold temperatures. When it gets too cold, your body wants to conserve heat. So the blood vessels in the skin undergo vasoconstriction. They shrink down. So less blood travels to the skin. It gets shunted towards the internal organs there. And then our skin is loaded with lots of different types of receptors. As you know, receptors monitor stimuli, both external and internal. And so our skin is going to give us large amounts of sensory reception, and it's going to transmit that information to the central nervous system or our control center. And so this extensive innervation allows for us to be able to detect a variety of stimuli that is going to occur, some potentially harmful, right, like pain, even temperature-wise. Okay, if it's too hot, you need to get out of the sun, or if it's too cold, you need to move in from the cold, right? So again, skin is a wonderful organ that it allows for us, all right, to be able to monitor all the sensory receptors there. All right, so let's move in and talk about the integument here. All right, so there's 2 layers to your integument. The epidermis, which is the outer layer, right, and that is made up of stratified squamous epithelium. And so by knowing that, one of the characteristics of epithelium is that it's avascular. It does not have any blood vessels. So you would be right to say that the epidermis is avascular. There are no blood vessels there. One of the questions that I like to ask on tests is if you get a paper cut and you notice after you cut yourself that you're not bleeding, then you can assume that that paper cut only cut through the epidermis. It never made it down to the dermis, which is the deeper layer. That's where the blood vessels are. Great question. So the deeper layer of our integument is the dermis. And it's going to be where we find the majority of the tissue there is going to be what we call connective tissue proper. But pretty much it's going to be specifically dense irregular connective tissue. That's another test question that I've seen on tests before. Dense irregular connective tissue is the primary tissue type in the dermis. Now, this third structure that is mentioned here, the subcutaneous layer or the hypodermis, sits beneath the dermal layer. But it is important that you know this, that the subcutaneous or hypodermis layer is not part of the integumentary system. That's a great true-false question for you. I'm giving you all these pearls of wisdom, folks, so don't miss out on it. And the 2 types of connective tissue that are present in the subcutaneous layer is going to be the adipose and the areolar. So if you look at those, you're like adipose and areolar, okay, that's connective tissue, specifically loose connective tissue. And what do we know about loose connective tissue? There's a lot of ground substance, which means there's a lot of space for stuff. And so loose connective tissue can be very vascular, lots of blood vessels, which is true. Subcutaneous layer has lots of blood vessels in it. Nice picture here of all the different layers of the integument. We're going to be going through this. But if you look at this picture, you'll notice there's a lot going on. We see hair, all right, we see a bunch of cells, we see some sensory receptors, we even see some muscle tissue there, okay? So again, we're going to be going through all this and reviewing this. So let's start out with the outer layer, the epidermis. And our epidermis is made up of 4 to 5 layers, depending on if you're in thick skin or if you're in thin skin. All right, thick skin has all 5 layers or strata. Thin skin has only 4 strata or layers. So the deepest layer, we're going to go with the deepest layer here, is the epidermis is the stratum basale. And you should know both of these other terms. Okay. Stratum Germinativum, all right, and Stratum Basale. Now, sometimes in my other classes, I refer to the Stratum Basale, just, I know it's phonetically incorrect to say, but the E at the end so you don't forget the spelling, because the E is silent. But this is the deepest layer, which means just below this layer, our basement membrane is hanging out. And then below the basement membrane is going to be the connective tissue. So it's one single cell layer thick. Now the cells of this layer will appear to be cuboidal, or what we call low columnar. And that's true. Now remember, when we're naming stratified epithelium, we're always naming it after the shape of the cells in the apical layer. So we'll talk about the name of the apical layer in a moment. It's called the Stratum Corneum. So when we're talking about the epidermis and the epithelial tissue there, we refer to it as stratified squamous epithelium because the apical layer is, they're squamous in shape. But even though in this layer here in the stratum basale, right, it's going to be cuboidal, or what we call low columnar. So there's 3 types of cells that we see here: the keratinocytes, the melanocytes, and the tactile cells. The keratinocytes, these are going to be the predominant cell. They're the most abundant. They're going to make the protein keratin, which is eventually going to kill the cell. So these cells are destined to die, as most cells are, okay? But once they start producing this keratin, this protein, then they're starting to kill themselves off. The melanocytes, right? We've heard of this substance before, melanin, right? The melanocytes are going to produce the melanin. They'll store the melanin, and not only that, they'll share the melanin with other cells in the area. How nice of them. And its job, the melanin, is to protect the DNA that lives inside the nucleus. So what will happen is, all right, the melanocytes will make the melanin, they coat the DNA, or excuse me, not the DNA, the nucleus. And so it protects the nucleus from ultraviolet radiation. Where at the same time, it gives us a pigment or skin tone coloring. The interesting fact is all of us have roughly the same number of melanocytes, but certain people's melanocytes produce more melanin, so they'll have darker skin tone. Some people like myself, my melanocytes don't produce a lot of melanin, so I'll have a lighter skin tone. The last type of cell is the tactile cells, also known as the Merkel cells. Now, when these cells are touched or compressed, they release a neurotransmitter, a chemical. And that neurotransmitter will stimulate these receptors that are nearby. They're sensory receptors. And then the sensory receptors will send that sensory input to your central nervous system, your control center. So the tactile or Merkel cells are going to send sensory input regarding touch to your central nervous system. So the next layer is the Stratum Spinosum. This layer is more superficial. It's right above the Stratum Basale. And so what we'll see is in the Stratum Basale, right, a lot of those cells are dividing. And so the keratinocytes divide, where you had 1 cell, you now have 2 cells. And so one of those 2 new cells, or what we call daughter cells, one of the daughter cells will stay in the Stratum Basale because it'll divide again. And then the other daughter cell will migrate into this layer here. And so when they migrate into this layer, right, this is where they start. It's like kindergarten. You go to kindergarten, you start to learn how to form relationships with your classmates. Well, that's what happens here. The daughter cell migrates into the Stratum Spinosum. And so it's going to start to create these junctions between themselves and the neighboring cells, the other keratinocytes, because they want to make everything tightly packed and they want to make sure that nothing can squeeze in between the cells. So they create these junctions, and they also create these desmosomes. And just think of those structures as anchoring structures. So the cells can be tightly packed with one another. Now, another type of cell that we find in this layer are going to be our Langerhans cells, or our epidermal dendritic cells. And so we'll see them in the Stratum Spinosum and in the Stratum Granulosum. I mentioned them before. These are our immune cells. So they can initiate an immune response if they come across a foreign pathogen. And they're constantly monitoring the cells in their vicinity to make sure that all is well, that all is normal. If they detect any abnormal cell growth, they'll immediately destroy the cell or cells, all right, through phagocytosis. What's that? All right, here's an abnormal cell that's growing. The dendritic cell will come along and gobble it up like a macrophage. Eat it up, kill it, dead. Problem solved. Our third layer of the epidermis is the stratum granulosum, right? 3 to 5 cell layers thick. This is where we start the death process, also known as keratinization. And so as the cell starts to produce this protein, it's going to fill up. And as it does that, the organelles will start to die and disintegrate, as will the nucleus, right? When we can't see a nucleus in a cell, right? Now there's certain cells that don't have nuclei, for example, the red blood cell, right? But keratinocytes should have a nucleus, right? Unless they've produced keratin, right? Then they're dead, right? But these skin cells, right, if they don't have a nucleus or the organelles, right, they're dead. But even in death, they'll serve a purpose, because they'll migrate into this layer here in the stratum lucidum. Now this is important. Okay, you're only going to find this type of epithelium in thick skin. Great question to ask. And there's only 2 places that thick skin exists for us, right? Palms of your hands, soles of your feet. That's it. Everywhere else is thin skin. And if you notice where they're on the palms of your hands and the soles of your feet, there's no hair there. So you should not have hair or hair follicles or anything associated with a hair or hair follicle in thick skin. And we'll talk more about that later on. So again, in this layer, the cells are continuing the keratinization process, right, where they're starting to mature, okay, where we're really starting to form that hardy, tough cell, right, because we need it as a protective layer in the outer layer of our epidermis here. Right, so we'll see, and it's always interesting to me that this layer helps to protect you from ultraviolet radiation, because what good, I don't really, point my feet up at the sun all that often. So the soles of my feet, I think, are pretty safe in the palms of my hand. But regardless, this layer, all right, will help with protection from the ultraviolet radiation. And then finally, our last outermost layer, the most superficial layer, is the stratum corneum. Okay. It ranges between 20 to 30 layers, but again, these cells are dead. And because of that and that keratinization process, all right, the outer layer, this is what you're looking at when you're talking to somebody. You're seeing their stratum corneum. So this layer is, yes, it's thickened and it's dry, which is good, because the dryness of the stratum corneum makes it more of a hostile environment for certain pathogens, certain bacteria, certain parasites, right? The thick portion helps with any type of mechanical stress or abrasion, right? So it's great in that regards. All right, so roughly it takes about a month for cells, all right, to move through the integument. It takes 2 weeks for the cells to get from the stratum basale into the stratum corneum, and then roughly about 2 weeks they'll spend in the stratum corneum. So roughly about a month for your skin to turn over. So there's a couple different variations that we're going to see in the epidermis. All right, we're going to talk about those now. All right, there's thickness, color, and then skin markings. So I already mentioned thickness here, but I want to go into a little bit more detail. You need to know where the thick skin is. So thick skin, palms of the hands, soles of the feet. And so thick skin is going to have all 5 strata. But you'll notice, okay, thick skin will not contain hair follicles. It will have sweat glands, because how many times have people had sweaty feet or sweaty palms? So we know for a fact it has sweat glands, but there's no hair follicles. And if you don't have hair follicles, you're going to be missing certain types of glands. And that is going to be the sebaceous glands. The sebaceous glands sit right on top of the hair follicle. If you don't believe me, here you go. There's the sebaceous gland right there. It's a lobulated gland. It sits right on top of the hair follicle, and it produces its oily sebum right on top of the hair. So if you don't have a hair follicle, then you don't have a sebaceous gland. See how easy it is to remember that? So in our thin skin, that's going to be everywhere else. Okay, the back of your hands, on your arms, scalp, all right, your legs, that's going to cover most of your body, which means we're not going to have a stratum lucidum there. Because remember what I said, that layer is only present in thick skin, not thin skin. But in thin skin, we'll have sweat glands, we'll have hair follicles. You don't believe me? Look at the back of your arm. Okay, there's hair there, unless you're shaving your arms. Okay, but that means you have hair follicles. So therefore, if you have hair follicles, you're going to have sebaceous glands. Okay, you have hair follicles, you have sebaceous glands. It's that simple. Okay, let's talk about the dermis now. Deeper layer, thicker layer. This is the layer where I tell folks this is where you're going to find all the stuff. Right, because our skin, our integument, has all 4 tissue types. We just saw epithelial tissue is in the epidermis. Now we're going to see, okay, in the dermis, a bunch of other structures that are going to be present. Okay, so primarily the dermis is going to be made up of connective tissue proper. There's 2 types of connective tissue proper. There's loose and dense. All right, so we'll talk about some of the specific connective tissues here in a moment. But if you notice, like I said, this layer has all the stuff. Look, blood vessels, sweat glands, sebaceous gland, hair follicles, nail roots, sensory nerve endings, erector pili. Right, the erector pili is smooth muscle. Sensory nerve endings is nervous tissue. Okay, blood vessels contains epithelial tissue. Sweat glands, same thing. All right. And we'll also see that there is going to be areolar connective tissue there and dense irregular connective tissue, which is the predominant tissue type in our dermis. So our dermis has all the tissue types there. So we break down our dermis into 2 layers, the papillary layer and the reticular layer. Okay, the papillary layer is the smaller of the 2. It's more superficial. The reticular layer is the bigger of the 2. It's going to be the thicker part. So just below, remember what we said, we have our epidermis, then our epidermis sits on the basement membrane, and then right below the basement membrane is our connective tissue. And that's the papillary layer, is the connective tissue. Predominantly made up of areolar connective tissue, which is a loose connective tissue, which means we'll see a lot of vascularity there. Well, that's good because epidermis is avascular. Okay, epithelial tissue is avascular. So how do we get nutrients to that epithelial tissue? Not a problem. Our papillary layer has all these blood vessels, and so the nutrients can diffuse out of the blood vessels into the epidermis, and that's what happens. So if you look, and I'll show you here, we'll see, all right, we'll see our epidermis and dermis will have this type of relationship between the 2. So these little bumps that project upwards, that's part of the dermis, the papillary layer, and then these little indentations that go downward, that's part of the epidermis. So these projections of the dermis, we call these the dermal papillae. They're just bumps that go up into the epidermis. And then the parts that come down from the epidermis, that is going to be called the epidermal ridges. That's these guys right here. And so they create this interlocking mechanism between these two layers. And because of that interlocking mechanism, all right, that's how we generate fingerprints. Okay, we call those friction ridges, essentially fingerprints though. Then our deeper layer is going to be the reticular layer, all right? And pretty much that's where we're going to find a lot of stuff, but that's where we're going to find the dense irregular connective tissue. All right, so here you can see this interlocking mechanism between the epidermis and the dermis. The epidermal ridges are downward bumps, and then the dermal papillae are upward bumps that come from the papillary layer. And we can't talk about the integument and not talk about the subcutaneous layer, also known as the hypodermis. Again, let me reiterate, it is not part of the integument. It is separate. It is made up of loose connective tissue, specifically the areolar and adipose. And because we have adipose here, and if you look at the functions below, you can understand why this layer has those functions: protection, energy storage, and insulation. Well, we know that adipose tissue is going to be utilizing lipid storage for triglycerides, so that makes sense. But also, adipose tissue is useful in regards to cushioning of some of our organs. So that's how it offers protection. And also insulation. The more adipose tissue you have, the warmer it can keep you. Right? Well, like I said, this is a loose connective tissue. And we know that loose connective tissue is an area that has a high level or has a large amount of vascularity, okay? And so that's why we use it as a drug injection site, because of all those blood vessels in that area there. So we can get it into the blood quicker. All right, I'm gonna move in and talk about the nails here for a few moments, okay? There's really nothing terribly exciting about nails. I'm not trying to dissuade you, but I just want you to know, just bear with me on this, okay? So let's talk about the nails. All right, our nails are actually a specified modification of the stratum corneum. So the outer layer of your skin, okay, the outer layer of your skin has, all right, been modified into this hard material, which is going to be the nails that you see on the tips of your fingers and on the tips of your toes. And so what that modified material will do is helps to, yes, protect the tips in case you drop anything, and we've all done that, all right? And sometimes when it's fallen on my nail, I'm grateful because it could have probably hurt a lot more if I didn't have a nail there. But also, how many times have you used your fingernails to pick something up or pick at something? I use the example of a sliver, okay? If I've gotten a sliver, I'm using my nails first before I give up and go and get tweezers, okay? But it helps in grasping things. All right, so let's talk about the nail. So the actual hard part of the nail is referred to as the nail plate, and it's made up of 3 different regions. So if your nail's ever fallen off, that the thing that's fallen off is called the nail plate. The part that you cut when you're cutting your nails is called the free edge. And so it looks white because there's no blood vessels or capillaries underneath it. Now, when you're looking at your fingernail, all right, you can see on the fingernail, here's the nail plate, okay? This whole thing right here, that's the nail plate. So if your nail ever falls off, there goes the plate, but it's made up of 3 parts. The outer portion here, that's the part you clip off, that's the free edge. And it's white because there's no blood vessels underneath it like it is here. okay, when we look at the nail body here, okay, you can see in this area here, all right, this is where you'll have the coloration, the pinkishness there. And that's because of all the capillaries that lie underneath. Okay, so that's the nail body. And then the third part you can't see because it's underneath the skin. That's the nail root. And so as the nail grows, it pushes out towards the distal portion of your finger. Underneath your nail plate is going to be the nail bed. And that's made up of that living, all right, epidermal tissue. Okay, it's this pinkish looking tissue that sits right underneath the nail bed, the nail plate. So the nail matrix, okay, similar to the hair matrix, if you've studied that at all in lab, right? The hair matrix is the actively growing region of the cells there that's going to push the hair towards the surface of your skin. Well, the nail matrix, same thing. This is the actively growing portion of the nail, and it's going to have the cells that are dividing and reproducing. And so it'll push the nail towards the tip of your finger there. Now, if you notice here, you have a whitish structure here that's called the lanula. And it's white because that is an area of thickened tissue to where you can't see the capillaries underneath anymore. So that's why it appears white. I always think of it like a moon, okay, like the lunar moon, okay, and the moon will appear white at nights because of the reflection of the sunlight, okay, so that's the lanula. On either side of our nail, all right, where the skin meets up with the nail body, those are the nail folds here and here. Okay, and then we have the last two structures. You may have heard of the epiconium before by its other name, the cuticle. The cuticle is this thin, small, narrow band of tissue or skin that comes off of the epidermis onto the actual nail body there. Okay, so if you've ever gotten a manicure, they're usually trying to scrape that or try to help. You may have heard of that term before. And then the last structure is the hypoconium, right? And that is going to be this area right here, right underneath the free nail edge here, okay? If you cut that away, you'll see a thickened region of the stratum corneum. You may have seen it if you cut the nail too short. Okay, and you see that thickened region, that is referred to as the hypoconium. All right, that's it for nails. Let's talk about the hair real fast. All right, so there's 3 zones to our hair bulb, the root, and the shaft. So at the base of the hair, here's our hair, get a bulging here. Okay, so at the base of our hair where it kind of bulges out, that's the nail, that's the hair bulb right here. Okay, that's going to be found in the dermis. In some cases, it could be found even below the dermis here. But the hair bulb surrounds this structure called the hair papilla. So you'll have blood vessels going in here and then leaving, okay? And so this region here is referred to as the hair papilla. And so we're going to see, all right, the epithelial cells dividing in this area, and this is the only area in which you have living epithelial cells. The epithelial cells up here, dead. Epithelial cells over here, dead. Okay, the only area of living epithelial cells is going to be found in the hair papilla. Now, the part of the hair that's below the surface of the skin, so pretty much from here to here, that is going to be the hair root. It's below the surface of the skin. The part that's above the surface of the skin, that's known as the shaft. So above the skin and beyond is the shaft. Below the skin to the hair bulb is the root. The root, and then the hair bulb is going to be that bulging or swelling at the base of the hair. So here you can see it a little bit better. I know my drawings aren't the best. Okay, so here's the hair bulb right down here, kind of bulges out. Here's the hair papilla down in this region here. Then you can see from here all the way down, that's the hair root. And then above, here's the hair shaft. All right, so when we're looking at the actual hair itself, a couple parts of the hair that I want to discuss. The hair matrix, the medulla, the cortex, and the cuticle. The hair matrix, again, this is where those epithelial cells are dividing. All right, then once they've divided, all right, the new cells are going to move superficially towards the surface of the skin, and then they'll start to undergo the keratinization process, which means they'll start to kill themselves, and then they'll be dead. Okay, so we see the hair matrix. That is going to be located in the hair bulb. Then as those cells start to move up and the hair itself starts to kind of thin out, all right, into that kind of long cylindrical structure, now we're going to talk about the other parts of it. All right, we've got the medulla, the cortex, and the cuticle. So the medulla is going to be in the center of our hair, and the cuticle is going to be the outer covering. And so the cortex will be found somewhere in between. Now, these two terms, medulla and cortex, you're going to see that used throughout this course, describing certain anatomical regions of certain structures. For example, the adrenal gland. The outside of the adrenal gland is called the cortex. The inside is called the medulla. And it's covered by the capsule of the adrenal gland. Okay, so here, right, the hair is no different. The inner portion, the middle, is going to be called the medulla. And so we're going to see here, we'll have keratin, right, but it's a soft keratin. So that gives that portion of the hair some flexibility. Now we're going to surround the medulla with the cortex. Now that's going to be harder, so it's going to have less flexibility, but more support and structure. And then there's one single cell layer that covers the cortex. So if we look here, okay, you can see this brownish line that goes in the center of our hair. That's the medulla, surrounded by this tan area there. That's the cortex, and this black or dark brown line, thin line that covers the whole thing, that's the cuticle. And all of that will make up the hair. And you can see it over here on our micrograph here. Okay, so here's the medulla, it's in the center. Okay, and then you've got your cortex here on the outside of it. And then this thin region here, all right, that is going to be the cuticle. All right, two other parts to the hair, and then we're done with hair. Okay, hair follicle and the erector pili. How I describe the relationship between the hair follicle and the hair is, it's like wearing pants. Okay, think of your leg as the hair and the pants as the hair follicle. Okay, so the hair follicle is going to surround the hair root. All right, so we're going to see the outer portion of it is going to be a connective tissue. And then the inner portion of the hair follicle is going to be epithelial tissue. Okay, so the outer is connective tissue, which is good because it's going to give it a little bit of protection and support. And so the outer portion has a structure that attaches onto it, which is called the erector pili muscle, which is smooth muscle, which means it's it's involuntary. And so you can't control how this thing works, right? And so when it does contract, when that smooth muscle contracts and it pulls on the hair follicle, it's going to create, all right, these bumps in your skin. We call those goosebumps. But basically, it's going to pull on that hair follicle, all right? And usually it will occur when there's a sympathetic reaction, that's part of your nervous system, all right, or when you're cold, because it helps to retain heat when you get these goosebumps, because when it pulls on the hair, it helps to position the hair to actually trap heat against your skin. All right, some of the functions of hair real quick: protection, facial expression, heat retention, sensory reception, all right, visual identification, chemical signal dispersal. Protection, the hair on your head, if you're a light-skinned individual like myself, protects me from getting sunburn. Facial expression, all right? I've had to utilize this more recently because people wearing masks, especially when I was teaching in class, if they're wearing masks, it's hard to really see their facial expressions, but sometimes if you look at their eyebrows, if they raise them inquisitively, like they're confused, they can help you with certain types of expressions. Heat retention, I just mentioned that with the goosebumps, all right? When that occurs, it helps to hold the heat against your skin. Sensory reception, I'm sure we've all been outside and a little gust of wind kind of blows our hair around or moves the hair on your arms or legs, and you can feel that. So you're able to tell what's going on in the external environment. Visual identification. People that have white hair or gray hair are assumed to be older. You're not going to assume that somebody's 10 years old if they have white or gray hair, unless they have some sort of genetic issue going on. Then chemical signal dispersal with our pheromones. When we become of age of puberty and we start to produce certain excretions from some of our glands, right? Some of those secretions will go onto the hair, and then when they dry, or it will evaporate off of the hair and into the air, and that will help with the pheromone distribution. All right, let's just talk about a few of the glands in the skin, our sweat glands and our sebaceous glands. All right, when we're talking about our sweat glands, we have the Merocrine and the Apricorn glands. Okay, the Merocrine glands are going to be the gland, they're our basic sweat gland. The majority of whatever that gland is secreting, 99% of that, of what it's secreting is going to be water, and then the other remaining percent will be solutes, all right, like metabolites, salt, whatnot. In the Apricorn gland, we're going to talk a little bit more about that. All right, so Merocrine glands, all right, these guys are going to be the most popular gland. All right, they are what we call a simple coiled tubular gland, which basically is this gland that it's a big long tube, and what we've done is we've rolled it up. And so it looks like that. And so their job is to discharge their secretions onto the epithelial surface of your skin. And so these cells of these glands are going to release their secretion by the process of exocytosis, which is basically these glands are going to make the secretions, package them up into vesicles. Those vesicles are going to travel to the apical surface of the plasma membrane of that cell, fuse with that plasma membrane, release the contents out into the duct, and then it'll get excreted onto the surface of your skin. So like I said, 99% of the sweat is going to be water. And then the other 1% will be the solutes or other chemicals, okay? Electrolytes could be sodium, chloride, magnesium, all right? Metabolites and waste products, especially urea, right? Which is a nitrogen-based waste product of cells. But these types of glands are very, very helpful in thermal regulation when we are sweating. Okay, that's a way that we are decreasing or cooling off, decreasing our body temperature if it starts to heat up too much. Apricorn sweat glands. The apricorn sweat glands are same type of gland. It's going to be a coiled tubular gland, right? But in this situation, right, we're going to find these glands in the vicinity of hair follicles. So they're going to release their secretions into the hair follicles, and that's going to be located in the armpits or the axilla, around the nipples, in the pubic area, and anal region. Now, these glands are going to still produce their secretions and release it through exocytosis, but also, as it's doing that, that's where the whole apical region of the cell, the plasma membrane, gets pinched off. So here's the top of the cell, okay? So it'll pinch off this whole region right here. And that becomes part of the secretion. So that's why the secretions for these type of glands are going to be a little bit thicker or more viscous. And they're cloudy because they contain proteins and lipids. Where did it get the proteins and lipids from? Plasma membrane of the cell. And there's also proteins and lipids in the secretions. So this is why, all right, people will stink. Because, and it's not so much because of the actual secretions themselves, it's that you have bacteria that lives on the surface of your skin. And so it lives on the surface of your skin in your armpit. And so when these glands produce their secretions and it goes onto the surface of the skin and on the hair there, the armpit, the bacteria will feed off of that. And of course, bacteria are like babies. They like to eat and they like to poop. Well, the bacteria's waste products are going to be what produces part of that odor. That's why it's important to take showers, folks. So make sure you go tell your 14, 16-year-old teenage son to go take a shower because the bacteria have gotten the better of them. All right. These glands become active during puberty. So up until puberty, they're not doing anything. Once you get to puberty, they start to do something. All right, last type of gland that I want to talk about are the sebaceous glands. These are the holocrine glands. Now, when this gland does its thing, the cells of the gland just disintegrate. They erupt, they break apart, explode, whatever you want to say. And so the cell fragments become part of the secretion in addition to whatever that cell was producing. So this type of secretion will be viscous also. It'll have kind of an oily consistency to it. So these glands, all right, I showed you earlier, are going to be found on the hair follicle. So whatever they're making is going to be discharged onto the hair follicle. So it helps to lubricate the skin and the hair. It's these glands that kind of give that greasy appearance to people's faces sometimes, right? They just have active sebaceous glands. But the nice thing about these secretions, the sebum, is that they're bactericidal. They'll kill off bacteria. That's always nice. These are another type of gland that don't become active until puberty, and they are stimulated by hormones, but specifically androgens, which are the male sex hormones. All right, so there you can see these glands here, all right, of the integument. So here's a simple Merocrine gland, a simple sweat gland. All right, and so it has the sweat gland here, all right, and then you can see where the duct, all right, goes up to the surface of the skin. There's no hair around it. Now, when we get to the other two glands, here's the Apricorn Gland, all right, its duct, all right, is going to release or discharge its secretions right onto the hair follicle. Same with our sebaceous glands. So these two glands will be seen in areas where there are hair follicles. All right, let me just finish up here and talk about two more things. One is the repair and regeneration of the integument system. Okay, it's important that you know this. So quickly, there's two ways in which tissue can be repaired in your skin. Either regeneration or fibrosis. Regeneration is, this is the optimal one. This is the one you want, because basically any cells that were damaged or dead get replaced by the same type of cell, and all right, it restores the function. All right, but with fibrosis, unfortunately, that does not happen. Okay, damaged or dead cells, okay, will be replaced with scar tissue. What is scar tissue? Collagen. What cell makes that? The fibroblasts. Okay, so the fibroblasts come in, they lay down the collagen, and the area that was damaged or where the cells were dead, all right, is replaced with collagen. And so we do not restore function. Okay, regeneration restores function. All right, fibrosis does not. Regeneration replaces those dead or damaged cells with the same cell type. Fibrosis does not. It replaces it with scar tissue, which is collagen. All right, so the stages of wound healing, real fast. There's 4 of them. So we're going to use the example that you get cut. I'm going to go back and forth between this slide and the picture slide. So this is what we're seeing here. Here's our cut. You've gone down into the dermis, damaged some blood vessels, so blood starts to fill the area where the cut occurred. All right, that's stage 1. Second stage, now we start to clot the blood, so we prevent more blood from spilling into the wound. And now we bring in our white blood cells, the leukocytes. And so they come in and they start to clean the wound. So we've blocked out the external environment because we don't want any pathogens getting in. And that's what we see here. Here's our blood clot. So we block out the external environment. And then here you can see our white blood cells, the macrophages and the neutrophils are coming in, and they're already going to work, all right, on cleaning out the wound, making sure that if any pathogens got in there, we're killing those off. And we start to get rid of the damaged dead tissue. All right, so that's the second stage. The third stage is, all right, any blood vessels that were damaged, we need to regrow those. And now we're going to start to form, all right, our early scar tissue or our granulation tissue. Okay, so we'll start to fill in that area. So that's what we're seeing here. We're growing new blood vessels. Okay, and think about it, because the blood is going to be carrying our supplies that we need to fix and repair this wound. So we still have our macrophages in there. They're going to work by, again, killing any pathogens and destroying any damaged tissue. The fibroblasts are starting to lay down collagen, right? Beginning the repair process. So that's stage 3. Finally, stage 4 is our epithelial tissue now is going to regenerate, right? And we will have fibrosis or scar tissue in the connective tissue region. That's what we're seeing over here. You can see, all right, our epithelium has regenerated itself. And then down here, all right, we filled in that area with granulation or scar tissue. So that's pretty much the stages of wound healing. Okay, and then last but not least, of course, I told you at the end of these chapters, we're going to talk about the effects of aging. Last part. So as we age, some of you may notice this, especially if you have an elderly family member, okay? But what we'll see is, all right, the skin itself, all right, starts to become thinner. And part of that is, okay, the skin repair process slows down. Think about it. When you get older, you just slow down. Everything slows down, right? So because the skin repair process slows down, all right, our stem cells, you know, that stratum basale we saw in the epidermis, those cells aren't dividing as often, okay? So they've decreased, and the number of cells that actually are undergoing any division has also decreased. All of that causes thinning of the skin, right? We'll see less collagen because we have fewer fibroblasts. We'll also see less elastic fibers. So if we have less collagen, our skin is not as strong. If we see less elastic fibers, our skin is not as elastic. So we'll start to see wrinkles form. And because we have fewer dendritic cells, our immune response has been diminished. That's why older people are more prone to certain types of skin cancer than younger folks. And then we'll start to see, all right, our hair follicles, all right, will either stop working altogether, which is really unfortunate, all right, or the hair that they are producing is just going to be thinner, which is not uncommon for folks as they move into their 4th, 5th, 6th decades of life, the hair on the top of their head becomes thinner. But one of the things you always have to be careful is this guy, ultraviolet radiation, okay? Because it damages those epidermal cells, and it's a huge risk factor for cancer, but it will accelerate the aging process, right? And you'll see that in folks, and you know who I'm talking about because you might even know somebody or have a family member that when I used to live down in Miami, you know, a lot of people love the beach. They like going outside. They like their sun tanning. But I'll tell you what, there was more than one time that I made the mistake of somebody's age. And I thought that they were actually older than what they really were, but it was because they spent a lot of time out in the sun. So a big thing that you should know for this class, but also just in general, the number one type of skin cancer in the world, number one type of cancer in the world is skin cancer. It's 5 times more prevalent than prostate cancer, 5 times more prevalent than breast cancer in women. Okay, it is the most common type, right? You'll see it mostly on the head and neck because those areas are exposed to the sun, right? And folks like myself, fair-skinned individuals, have the highest risk of getting skin cancer, which is no bueno. So that's it. That's it for this class, for our review. Sorry that I went a little bit over, but I hope that you folks learned something. Do you have any questions for me